Hello everyone, how are you? Today I have one very exciting topic for you. We will deploy custom VPC infrastructure with AWS CDK and Python. In certain times, we have to deploy our own infrastructure of network and we have to build it from scratch. In this tutorial, I have tried to explain how to do it via AWS CDK. We will use Python as a programming language. We will provision VPC, subnets, route table, NAT gateway, internet gateways. We will also create all the routes associated with it. So this will be fun. So the code for this tutorial that I will be using is in the description box. You can go directly to the GitHub repository of mine and take the code from there. Lastly, if you are new to this channel, kindly share, subscribe and comment your thoughts. Let me know what you liked and what you didn't like. I will try to make some recommended video from you guys if you have any. So sit tight and enjoy. So as I said, in this part, we will be deploying a custom VPC and its components from scratch with AWS CDK and Python. So at the end of this video, we will have one VPC in our AWS account. Within that VPC, we will have one public subnet and one private subnet. And within that public subnet, we will have a public route table. The NAT gateway will be placed on public subnet and the NAT gateway will be assigned an elastic IP address. The route from the private subnet will be routed through the NAT gateway of public subnet, and the route from the public subnet will be routed to internet gateway, which will be available to communicate with other internet services. So if you remember from my previous video, we have done the similar infrastructure as code with Terraform. Now it's time to do the same infrastructure as code with CDK and Python. So basically I like this AWS CDK and Python approach. They have a very well documentation available. You can choose any language you want, whether it is Node.js, Java, but I will use Python here. And I will show you how this is very simple to deploy now a custom VPC, custom infrastructure as code with AWS CDK. So if I move on now, this is the same one where we will deploy the infrastructure as code with AWS CDK and Python. So we will use Python as a programming language and we will use Cloud Development Kits, CDK, for our infrastructure provisioning. And what we will do, so we will create a custom VPC. Also, we will create subnets, create the route tables for our subnets, private route table for private subnet, public route table for public subnet, and we will create internet gateway to communicate with internet. We will create NAT gateway in our public subnet to give internet access of the private resources, and then we will create an elastic IP address to attach it to the NAT gateway. We will also create custom routes so that everyone can communicate with each other, whether it is a public subnet resource or it is a private subnet resource. So everything we will do from scratch with Cloud Development Kit, CDK and Python. So let's go and create the practical. Welcome again. So before start of this practical, I will choose a folder, CDK VPC Infra. I have created this folder. And if we see currently inside this folder, nothing is there. So we will choose this folder and we will initialize the CDK project. So if you remember from the previous videos how to initialize a CDK project, the command is CDK init, and then I need one app and the language I need Python. So I need one CDK app of language Python. So this is the initialization of CDK project. So if you have not seen my CDK introduction, please go ahead and watch the video. You will understand what CDK init does. So my project initialization is done. What I will do, I will also activate my virtual environment. So I will copy this and I will paste it here. So my virtual environment is now activated, and I will open this infrastructure or this project with my IDE. This is my project. So I have opened this with IntelliJ IDEA PyCharm IDE. You can choose whatever IDE you want. So this is the project that I have opened up. Now this is the main stack. So this is the main stack that we will be using to provision our infrastructure here, and we need basically two files. So one file is to provision the infrastructure, and another one I will use as a constant or config file rather, to use that to give some constants there and use it in the infrastructure. So let's not waste more time and create one config file here. So I will create one config file here. So maybe I will choose a Python file and then config. So I don't want to add it right now. So my config file is here, and I have to give some constant here. So what is the idea between this config constant and the main stack? So if I want to reuse some functionality in my stack provisioning, I can use that from this config file. Nothing much. So what I'm going to do, I have uploaded the whole code here in this repository. I will give the link of this repository in the description box. Please go ahead and check that. You will find the link and you can download the code and you can provision your own infrastructure by tweaking some constants there. So I will also give that. So but in this video, I will also do it from scratch. So if you want to do it with me, let's go ahead and do it now. So for config file, I need some constants. So let's create for our first constants. So this is my VPC config. So I have given my VPC name as custom VPC. I need one internet gateway. The internet gateway name is internet gateway. The NAT gateway, I need one NAT gateway. The NAT gateway name I have given as NAT gateway. And the region I will be using US East 1. So this is the region that I will be using. You can choose whatever region you want. And the route tables, two route tables I will be creating. One is the public route table. The name is public route table, and the second one is the private route table, and the name is private route table. So these are a couple of constants that I need for the basic VPC provisioning. So also I need couple of subnets. So my public subnet is the name is public underscore subnet. So my public subnet is public subnet and the private subnet name is private subnet. So two subnets, two route table, one internet gateway, one NAT gateway. The region is US East 1 and my VPC name is custom VPC. So these are all the constants that I need basically to provision my infrastructure, VPC infrastructure. If we see the diagram here, we see that we have in our AWS account one VPC. My VPC name will be custom VPC. Yeah, one internet gateway. This is the internet gateway. One NAT gateway. This is the NAT gateway, and the region is US East 1. Route table. This is the public route table. This is the name. Private route table. This is the name. And two subnets. One is public subnet. This one, and another one is private subnet. This one. So now I need to create one map. So for route table, we need some mapping in the AWS CDK. So what are the mapping needed? Let's create that. So now I have created one map. So what is this map doing? So this route table map, this holds actually key value pair. So the key is public route table. So the couple of data or couple of values for my public route table, and similarly couple of values for my private route table. So public route table, it needs basically three values if it needs to be a public route table. So the destination CIDR block. So whenever from my public subnet, so this route table, remember this route table will be associated to my public subnet. So if in any public subnet, any user hits this CIDR block, it will communicate with internet gateway. So we need the gateway ID. That's why I have given internet gateway, and my internet gateway is this one, internet gateway. And the router type is EC2 router type gateway. And this EC2 is actually we have to import from AWS CDK. So AWS EC2 I have imported from AWS CDK, AWS EC2. This AWS EC2 I am calling this as EC2, only EC2. So this EC2.routeType.gateway. So for public route table, the route type should be gateway. So anyone wants to communicate in public subnet via public route table, the route will go to internet gateway always. Similarly, for private route table, anyone wants to communicate in private subnet, anyone wants to go to the internet, the private route table will route the traffic to NAT gateway, and the router type is NAT gateway type. Similarly, I have imported the NAT gateway from ec2.router type NAT gateway. So this is what it is distinguished between the public subnet, public route table and private route table. So if I see the diagram here, in my public subnet, we have public route table. This is this one public route table, which will communicate to internet gateway if there are any CIDR range that happens in this that falls in this CIDR range. And in my private route table, if they want to communicate with internet, that will go to my NAT gateway, not directly over the internet gateway. They cannot do that, because if we want to do that, NAT gateway will go to internet gateway, because basically if any private subnet resources wants to communicate with internet, so first of all they need to go to NAT gateway, and NAT gateway is in public subnet, so public subnet routes will automatically go to internet gateway via this public route table. So this is what it is. This is what this map is. This is the key public route table. This is the properties for public route table, and private route table. This is the properties for private route table. In our main stack creation, we will iterate through this map and we will create two route table. So that part is the next. Now we have to give same properties in a map way for our subnets. So this is my subnet configuration. My public subnet configuration, it needs four parameter. One is the availability zone, where my subnet will be hosted. My subnet will be hosted in US East 1A. The CIDR block is this one. My public subnet CIDR block is this. This is the range. And map public IP on launch, this I have given as true. Because this is what is distinguished between a public subnet and a private subnet. So for my public subnet, my map public IP on launch is true, and the route table ID is the public route table that we have created here. Similarly, for private subnet, the availability zone I have kept as in US East 1B, and the CIDR range is somehow similar here. I have given this 2 here, and then the map public IP on launch is false. This is the parameter actually distinguished between the public and the private subnet. So any resources which is launched in this private subnet will not be assigned a public IP by default. So that resource will be private. So this is, and the route table association for the private subnet is the private route table. Now my overall constant is done. So this is my VPC name is there, my internet gateway is there, NAT gateway, route tables, subnets, everything is there. Even the subnet map is created and route table map is created. Now everything is in place. Now let's go ahead and create the actual stack. Now here is my actual stack. I have one SQS demo kind of thing. This is given by AWS. I don't need it. I will delete this one. I don't want any unwanted code in my repository, so I will delete also this one. So first of all, we need to import couple of things. So what we need to import? We need to import AWS underscore CD, AWS underscore EC2, sorry, EC2 as EC2. And the second one, other than that, I don't think we need anything else, and stack is already there. So again, one more thing we need. What is that? Is our config file. So import CDK VPC infra dot config as config. So this is my constant file that I have imported. Now let's create the actual stacks. Now let's create the stack. I need one space here. This is my stack creation. This comes here. Now first of all, if we see the infrastructure here, first of all we need one VPC. So let's create one VPC. So how to create VPC? So to create a VPC, we need, this is my name. You can give any name you want, whatever name you like. So this is the one. This is how we create a VPC. Is called EC2 dot VPC. This is the VPC method that is needed. So sorry, this is for self, comma. We need one VPC name. So we know the VPC name we have described here is config.vpc. This is one we have already described. And we need the CIDR range. We need the CIDR range is here. I will give the CIDR range as 10.0.0.0/16. This is my CIDR range. And then I will give the NAT gateways, NAT underscore gateways. I will place the number as 0 because I will not give it something here. We will create something there. So subnet configurations. We need also subnet configuration. Configuration equals to this one is needed, and then we need enable DNS support. Enable underscore DNS underscore support. Support, this is a boolean value, so this is one true. And we also need enable DNS hostname. Enable, I think I have done some mistake, spelling mistake here. Enable DNS underscore hostname. Host names equals to, I will also give it as a true value. So this is how a VPC is created. So my VPC name will be config VPC, CIDR range will be this, and the NAT gateway currently is 0. We will create the NAT gateways anyhow, and the subnet configuration is something that we will also create. Enable DNS support is true and enable DNS hostname is true. So my VPC is ready, my VPC is created. Now what we need, we need to create one elastic IP. Why elastic IP is needed? Because elastic IP is needed for our NAT gateway. So let's create a elastic IP. So I will call it as self.elastic underscore IP equals to, this is also an EC2, and the main template for the elastic IP is reside here in this library, CFN elastic IP, CFN EIP. This is what it is called under EC2. So if I see here, let's see what are the things. So EC2 EIP. Then the scope will be, I have to define the scope self, and the name will be EIP. So this is how we define an elastic IP, and this is how we create an elastic IP. Now couple of methods we have to create. So first of all, we need to create internet gateway. So to create internet gateway, we need the same method. So this is how this is the internet gateway. So self.internet gateway, attach internet gateway, this method we have to create. So now let's create this method. Okay, so this is my method, attach internet gateway. So it will come here. So when I after creation of the elastic IP, so elastic IP I am creating here itself. So after creation of the elastic IP, it will create the internet gateway, and the internet gateway method is this one, where it will return internet gateway type EC2 internet gateway. What it is doing, so it is creating one EC2 internet gateway, and it will get the name of the internet gateway from my config file, config.internet gateway, and then it will attach the internet gateway to our VPC. So this is the VPC gateway attachment. So in the VPC gateway attachment, we need couple of parameters, the scope, the logical ID, internet gateway attachment, and the VPC ID. The VPC ID is the same one that we have created here. Self.bifrost VPC, this is my VPC, and the VPC ID. This one is needed. And the internet gateway ID. The internet gateway ID is the one that we have just created before this line. So this is how we create the internet gateway, and this is referring to this internet gateway. So this method actually attaching the internet gateway created here to our VPC created here. So this is how, if we see the architecture, this is how we attach an internet gateway to our VPC. So this is the method that does that. Now we have to, you remember we have created couple of map, right? So for that we need to create couple of map now, and we will create the map stack here. So to create subnet and route, to create the subnet and the route table map, or to hold the data, actually I have created two map. So this is the map is initialized here. The subnet ID, subnet ID to subnet map and route table ID to route table map. That means it will hold the subnet and the route table map that we will create now. So basically now we have to create the route table and the subnets. So let's create one by one. So first of all, let's create the route tables now. So this is the part where the route tables will be created. How it will be created, the scope is still self. So the create route table, this route table creation is actually here. It will come after the map. So we have to call now this one. It is called self dot create route tables. Now my route tables will be created. So this will call here in this method, and then the route table, what it will do, it will call the route table map, route table ID to the routes map. This is the one. So let's open it in the right side and split it here. So it will call this map and it will take the key. It will take the key, this one here. It will take the key here and it will first choose the public route table, and for public route table it will create the route table map. How? It will first take the route table ID. So this is my route table ID, public route table ID, and associated properties to it. So the route table ID is public route table, and then it will choose the VPC. So the public route table will be associated with this VPC, and then the tag it will associate with the route table ID is the public route table. It will also give the name as name, key as name, and value is the public route table. So this is how my route table is created. I think I'm missing one closing parenthesis here, so that's fine. So for each and every route table ID, for public route table and private route table, so it will take the key and create two route tables. That's it. This is how it is done. So if I see my infrastructure now, so my internet gateway now it attached to VPC. My VPC and internet gateway is created. Now my route tables are created. Still we need lots of things. So my route tables are created. Great. So if I come back here, now route table creation is done. Now we have to create subnets. So I will call my method as create subnets. So this is how it will create it. It will create. So create subnets. This method should be there. So I will define this method now. So I will create this create subnets method here. This one. So this is my create subnets method. So what it does, in the create subnets method, it is similar to the route table. If I see here subnet configuration, it will take the subnet ID. This is the public subnet. Suppose for the first one, first for loop, it will come here in the public subnet. It will take the subnet ID, public subnet ID, and the subnet configuration as a value, and the values as subnet configuration. This will take as a value. So this is the value. This is my subnet configuration. So in the for loop, it will create a subnet. The subnet ID is the subnet ID, public subnet ID, and the VPC ID it will attach to it. The VPC is the same VPC that we are creating. The CIDR block is the one it will take from the CIDR block. This is a dict dictionary. So subnet config CIDR block it will take like this, and the availability zone also it will take from here like this. And the tags, the subnet ID, public subnet ID, it will take, and the map public IP on launch it will also take the property here from this dictionary, and it is true. And the subnet ID to map. So this is how I am populating this map. Why this map is needed, I will tell you a bit later. So this map now I am populating with the subnet ID, that is the public subnet ID. That is my public subnet, and the subnet, this is the value of, this is the properties of this subnet. So this is how I am populating this map. So my subnet creation is also done. This is how we have created the subnets. My subnet creation is done. Now create the subnet and route table association, because my route tables are there. Two route tables, if you remember, public and private route table I have created, and the subnets are created now. My internet gateway is also there. So I will attach my public subnet to public route table and private subnet to private route table. Let's do that. So to do that, we need one method. I will call maybe this method as self dot create subnet route table association, subnet route table associations. That's it. So this is the method that is responsible for creating this subnet and route table association. Now let's create the method. So I will create the method here. So this is how the public subnet route table associations is done. What is done here? Let's see. We have the subnet ID again, and taking from the subnet configuration dot items like this one. It will take two items here, public subnet and private subnet. So suppose for public subnet, and the route table ID it will get from the subnet configuration here, the values, and from this dictionary is the public route table. This will take as the route table ID. So this is my route table ID. So public route table. So for the public subnet, the route table ID will be public route table. And then there is a property in VPC called subnet route table association. And in this property, I have to give the subnet ID first of all. So my subnet ID is the one in the map. This is how we have populated the map. If you remember from this method, from this map, we are getting we are passing the subnet ID, that is my public subnet, and we are referring to the value of the map. So the subnet ID it will take it will refer to the public subnet that we have given in the map, that we have inserted in the map. And then the route table ID, the route table ID is also that we have to populate anyhow, that we have to populate, and then the route table ID it will refer from there. Also I can show you where we have populated the route table map. So this is how in the create route table, if you remember the first method, the create route table, whenever we are creating the route table, it has populated this route table ID map with the route tables, that is the public route table and private route table. So there is two map, subnet map and the route table map. Now we are associating the public route table to public subnet and the private route table to private subnet. So this is how the association is done. Great. Now we have to create the NAT gateway. So to create the NAT gateway, we need another method called self.NAT gateway equals to, maybe we will create a method called attach underscore NAT underscore gateway. So this is the method I need. So let's create the method now. Okay, so here let's create the method. So this is how I created the NAT attaching NAT gateway, this method. So this is also a EC2 property where CFN NAT gateway, and the NAT gateway is the one where EC2 CFN NAT gateway. I am taking the NAT gateway name from my config file. The allocation ID is the one, the elastic IP that we have created before in this method. This is how we are taking the allocation ID. And then the subnet ID. So NAT gateway will be placed in the public subnet, remember. So we are taking that self.subnet ID maps from the map itself, and we are passing the public subnet name here. This is the name that we are passing, and we are referring to that. So my NAT gateway is attached to my public subnet, and then we are returning the resource that is created via this method, and we are holding this value here. Why we are holding this, I will tell you a bit later. Now remember, one thing that we have to keep in mind is that NAT gateway can only be created when the elastic IP can be creation is done, right? So for that, I am just for fail-safe purpose, I have given one property called self.NAT gateway, this one. So this is why we need it. We need to store the value. I have given as add depends on. So this NAT gateway depends on what? This NAT gateway depends on elastic IP, and it depends on this elastic IP. So the elastic IP that we have created before. So this is the elastic IP. So I'm saying this NAT gateway is depend on elastic IP. So NAT gateway will be created after elastic IP is creation. Elastic IP creation is done. Now everything is done. Everything is in place. What next is the route. we have to create the actual routes. So for that we need one method called create routes. So for this we will create the method now. So let's create the method. So this is how I have created the routes. So let's go one by one what it does. So if you see, it is taking the route table map, route table ID map. This is this one, and it is again checking the value. So from there it is taking the public route table. So for first of all, let's go ahead for check for one first for loop. So for this for loop, it is taking the public route table, and it is taking the length of the routes, that is this one, and then the route is the first parameter it is taking, and the route table id. Then the route table id is referring to the one that is passed by public route table. So for the first for loop, it will take as the public route table, it will refer to this one. And then if it is saying that if the router dot route type, that is the element of this router, this is the dictionary, the element of this dictionary, the router type is gateway. If the router type is gateway, then the gateway id is internet gateway, it is referring to the internet gateway. And if the router type is NAT gateway, that is the second for loop when the private route table will come, is NAT gateway, it is referring to the key ID as NAT gateway ID, and it is referring to the NAT gateway that we have created. And then it is creating the route. This is how it creates the route with the route table ID, and it will pass the arguments. So this is how the routes is created. Very important part here. This method is actually very important method in our whole stack. If you don't create the particular route properly, then the stack will not work, the stack will eventually fail. Sometimes I also felt a very difficulty here while deploying. I remember I have done some mistake here, like I have not given the NAT gateway ID to the NAT gateway. So I was also giving the gateway ID here, but there is a property in the route where we have to put the NAT gateway ID in the NAT gateway itself, not the gateway ID as NAT gateway. So please do remember that. Otherwise you will the stack will every time fail, as that it is not stable. So I'm rolling back and everything, blah blah blah. So this method is very important. This is actually taking the once again, this is actually taking the items from my route table, and it is routing the traffic. If it is a gateway route, it is referring to the internet gateway. If it is a NAT gateway route, it is referring to the NAT gateway route. So this is how we created the entire stack. Now everything so far so good. So what we have to do, we have to deploy the stack now. So to deploy the before deploying, we need to configure our AWS credentials first. So, and also we need to change this app profile here. So here we will deploy, we need to bootstrap it. So let's first do the AWS configure, and then let's go to the management console and take out the take out this account ID. So I have opened up my AWS console and I have taken the account ID. I will paste the account ID here. This is my account ID, and it will deploy the stack in US East 1 region. My stack is now ready. It is ready to create the VPC, the Elastic IP, Internet Gateway, NAT Gateway, all the routes associated with it. Everything is ready. Now what I will do, I will go ahead and do CDK bootstrapping. So CDK bootstrap. I have also configured the AWS credentials. So if you have not done that, please do that before bootstrapping is needed. So I think some of the thing is missing. So let's see what is missing. It says that I might have done some spelling mistake. Let's see. So I think what I have done is like this. This is the one. So I have given everything in caps. So everything should not be in caps. So what I will do is I will again clear the screen once. CDK bootstrap. So if I do bootstrap now, it should work. Let's see. Okay, it is bootstrapping, and the bootstrap. the environment is bootstrapped now, so it should create everything as it is. Everything is there, so it should create the VPC and everything. So let's see. Now do some CDK. Do the main CDK command, do CDK synth. So if I do CDK synth now, it should create the infrastructure as code with this CloudFormation template. So everything is created. Now let's go one by one. So first of all, it is creating one VPC. This is the CIDR block that I have specified. It is creating one Elastic IP. It is creating internet gateway, VPC gateway attachment. It is doing route table, then public route table. This is the route table which is private route table. Subnets it is creating. This is another subnet. This is the subnet route table association. It is creating the NAT gateway. This is the main route. So this is the route that it is creating. So whenever the destination CIDR block is this one and public route table, it will refer, and the public route table will refer to the gateway ID. And then the second route is the private route, where it will reach anywhere the destination CIDR block is this range, then it will refer to the NAT gateway. So everything seems to be okay. So what I will do, I will again clear the screen and I will do CDK deploy. Let's see. Uh-oh, I think I have done one mistake here. So what I will do, CDK deploy. So it will deploy my infrastructure as code to this account that we have configured. So let's see. Let's wait for the deployment now. So I can see the change stack is completed. Now let's go to our management console and see. So this is the management console that we will be checking our infrastructure has been provisioned or not. So first of all, let's go to the CloudFormation. So if I go to CloudFormation, I see that this is the bootstrapping, and this is the infrastructure, and this infrastructure is created, and we see that couple of resources are created. My custom VPC, internet gateway, NAT gateway, private route table, public route table, everything is created. Now let's go to VPC. If I go to VPC now, and inside your VPC, I see that this is the custom VPC that is created. This is my VPC, and if I see the tag, this is my tag that I have given name. This is the one, and then if I go to subnets, I see two subnet should be created. Yes, one is the private subnet and another one is the public subnet. So for private subnet, I see that I will only check this auto assign public IPv4 address. This is no. This is my public subnet that I have deployed, and this is the name private subnet. Private subnet I have deployed, and for public subnet the name is public subnet. And if I see the map auto assign public IPv4, and this is yes. This is fine. So this is my. So if I go to route table now, two route tables are created: public route table and private route table. For public route table, the tags is public route table, and the details is this route table association ID. We will go to this one. So this public route table is associated with this subnet, public subnet. If I go to subnet association, we will be able to see this as a public subnet association. Similarly, if I go to private route table, we will be able to see in the subnet association the private subnet association. In the internet gateway, we will also see that our internet gateway, I hope this one is created. Yes, this is the internet gateway that we have created here, and this is attached to the VPC that we have created. Apart from that, we have not created anything, and the elastic IP that we have created here, this is the elastic IP. I hope there will be an allocation ID with our NAT gateway. Yes, this is the allocation ID with our NAT gateway. Now if I go to our NAT gateway, we see this NAT gateway has been created, and the IP for this NAT gateway is this one. This is the elastic IP that we have created, and this is in public subnet. This is placed. Secondary IPv4 we have not created, and the tags is the NAT gateway. So we have seen that we have used actually this CDK, AWS CDK with Python to provision our infrastructure as code. So we have provisioned the whole infrastructure, our VPC, subnets, private subnet, route tables, and NAT gateway, everything infrastructure as code with our AWS CDK and Python. So this is the agenda of this tutorial, and I hope you like this video. So this is what I wanted to show you. If you are new to this channel, kindly like, share, subscribe to my channel. Please give your comment on the chat box, and also let me know what you want to know in future in this channel. I will also try to update you on the upcoming trending technologies that we have in cloud, and also we'll be back with another exciting video. So till then, take care. Goodbye.